Are you curious on how Lambda works? Do you want to know what is the dark magic behind Lambda? If that's the case, maybe this interview is very interesting for you. I will be interviewing Marc Brooker. He's a principal engineer at AWS, and he was one of the persons behind building AWS Lambda as we know it today. He will talk with us about technologies like Firecracker, Rust, and other things that make Lambda so powerful as we know it today. So let's get started with the interview. Hello and welcome to another episode. I'm super excited about the guest we have today. I've been following this guy for a really long time, and I'm super excited that he accepted to have an interview with me. We have Marc Brooker. He's a senior principal engineer at AWS. He's working in the database services, but we are not here to talk about databases. We are talking about magic and Lambda magic. So I'm super happy to have you here, Marc. How are you doing?
I'm great, thanks, and it's good to be here. Very, very excited to talk about Lambda and talk about magic and talk about all kinds of things over the next hour. So yeah,
I'm super happy. You're going to tell us all the dark magic that Lambda has underneath.
I hope so.
I think this will be very educating for all the curious people out there like me. You have been in AWS like forever, like 12 years. That's like so long. How it's been, how it changed over the years?
Yeah, it's I've been at AWS since 2008. I joined AWS just after grad school, and back then we had EC2, we had S3, we had SQS, and I think that was the whole of AWS when I joined. And it was the small thing, rapidly growing. Cloud computing was beginning to be this thing people were talking about, and there was a lot of excitement about it, but when we talked to big customers, they'd be like, oh, well, why would I buy compute services from a bookstore? What is this cloud thing? Are you still going to be in business in 2 years? What if you get bored of this or somebody else needs the capacity? And so, it's been really fun to watch it grow from those early days where nobody really knew what to make of this whole business model, and the fact that it was Amazon, and the fact that it was, there were all these services, and just see that grow in terms of, now hundreds of services and, huge numbers of customers, and it's just been this real kind of transformation in the industry. Being part of that has been super exciting.
Yeah, and I think I'm a super fan of serverless, like everybody knows. And for me, Lambda has been like a huge transformation on the way that we do software and the way that like we mashing applications, like not thinking about a box that does everything, but thinking a little pieces that you glue together, and you rely on a lot of managed services, and a lot of magic happens. So when you joined Lambda, how that happened?
Yeah, so I'd been working on storage for a long time in the EBS team, and I was looking for something new, and I'd been listening to customers, and basically, folks were saying, the cloud has been this great journey. I don't own my data centers anymore. I don't have to worry about power, and I don't have to worry about cooling, and laying concrete slabs and all of that stuff, but there's still too much to worry about. And so I have to worry about servers, and I have to worry about scaling them up and down, and I have to worry about patching, and all of these other things that just come with being a good manager of a server infrastructure. And so as I was looking around for something new to tackle in AWS, I chatted to Tim Wagner back then, who was the founder and general manager of the Lambda team, and I was very excited about what he was saying about this thing that they were building, and we the team announced the preview at reInvent that year. I think it was 2015, and it was just super exciting. And so I thought, well, I want to tackle these big problems. I want to simplify things for customers, and serverless seems like the logical next step in that journey. And so it seemed like an obvious career move for me, and I was really, really glad to have done that.
Yeah, I think for me, like S3 is like the origins of cloud. It's been serverless. So for me, anything that goes in that line, like Lambda, like removing all the pain for anybody to put their applications and make their crazy ideas, it's like amazing. So I can I can see how you jump into that train as soon as possible because
Yeah, and that's actually I think a really interesting point. Like the first AWS services, S3 and SQS, were very serverless, right? Like there were no servers to manage, and to an extent, EC2 was the outlier when it launched.
Yeah.
Where we were asking people, "Hey, you've got to manage these servers and
learn all this networking and things
exactly.
that we were no."
These things people, and some people know them, and that's great. But it's a lot to learn to be able to do all of that stuff, and so. Lambda was, in a sense, kind of going back towards the original vision or the original steps of AWS.
Exactly. So what was the first big thing that you encountered when you jumped into this Lambda train? What you were working on, or what was the first big challenge that you needed to solve?
Yeah, so I think in the early days of Lambda, the team had a set of use cases in mind, and it was very kind of web and mobile backends, and really really good, interesting stuff, and a bit of data processing. There was the S3 event integration was one of the first things Lambda launched with. But as we started talking to customers, they just wanted to do things on Lambda that we had never imagined. And we talked to a customer that was doing, these huge data processing, kind of scale out nightly data processing kind of batch jobs on Lambda, which was, I think, in retrospect, a fantastic workload to put on Lambda, because you just, you could scale up, you could scale down, you don't pay for idle and all of these other things. But it was just such a surprise that people wanted to do that.
But I think that's the amazing thing of AWS, that we are listening to customers all the time. So we have an idea of what to build, and then customers have a totally different one. And it's like, oh, that's even better than what we thought that this could solve. And let's make it for that thing.
Yeah, and I think that's a great point, because we'd talk to customers and they'd say, "Are we allowed to use Lambda for this? Like, are you going to shut us down?" And we'd say, "Sure, you're allowed to use Lambda. We love it.
Exactly.
It's not what we expected, but absolutely."
So they were doing all these crazy things in the night, data processing, and what happened?
Yeah, and I think because we had to an extent designed for the less bursty stuff, like like mobile and web, where there's a fairly kind of constant kind of day in and flow as folks wake up, and these big really spiky jobs where folks were starting up clusters of thousands or tens of thousands or hundreds of thousands of Lambdas really just stressed the system, and we had to pretty quickly redesign a couple of the core components to be able to deal with the sudden spikes of scale that customers wanted to send. And it was great business to be in, but it was also something that to an extent the original versions of the system weren't entirely designed for, and so there was some very early evolution we needed to do to get it to scale up and hit those numbers and hit the ramp rates of just like adding concurrency and adding workers, and teaching the system to tell the difference between intended scale up concurrency and unintended things,
all the things that the customer didn't need to worry about that you needed to worry about.
Right, exactly. And so it's good because we get to worry about it once and fix it and figure out a great algorithm, and then lots of people, hundreds of thousands of customers can take advantage of that.
Yeah, so that was one of the first re-architecture that Lambda suffered.
Yeah, I think it's a journey of every AWS service that we are more or less continuously re-architecting things. It's never these big pauses. It's always this more scale, more regions, more zones, more features, and it's one of the really fun things about working at AWS.
Yeah, and I think for customers it's great because they get advantage. I think one of the biggest advantage I see through the years is the cold starts that a lot of people have in their head that Lambda has cold starts and they're, no, go and try it again. That's not a big issue. And how that was in your side, because I imagine people were like, serverless, we cannot use it. It has cold starts. It's like, no. How you suffer that?
Yeah, that's actually also been a really interesting journey. We started out and I think at the beginning almost accepted that cold starts would have to be a fact of life. And our customers challenged us on that correctly and said, no, we aren't willing to deal with this. We aren't willing to put up with cold starts. And so we had to think about, how do we get real creative about making them go away. And so, that's been a lot of optimization on the back end. And, some of it is to an extent the kind of simple stuff of just moving data around faster and, making things happen faster and profiling and optimization. Some of it has been features like provision concurrency, where you can say, well, I want to, I want to have this number of workers or concurrent executions of my Lambda ready to go at any time, and the hookup with auto scaling and so on with that. And then some of it has been actually some really interesting deep architecture work, and we can talk about this a little bit more if we talk about Lambda container support. But
yes,
there's been fantastic work the team's been doing to hide and optimize. And then probably as a fourth thing there's been some great work from the community on thinking about cold starts, because in a traditional serverful environment, it doesn't really matter how long a Java process or whatever takes to start up. And I think as we've done serverless and as containers have become more popular and as folks have invested more and more in auto-scaling, suddenly, these long cold start times of both the JVM and the code and whatever have become a problem. And, folks working on the JVM, folks working on frameworks have done a fantastic job of also meeting those, meeting the new customer expectations. And so we've seen the whole ecosystem just get better and better for serverless over time.
Yeah, serverless has amazing community. It's one of my favorite things from the serverless ecosystem. Like, people are super active and building all kind of things. But I think also the platform allows that you can bring your own runtime, or now with the container support, do all kind of crazy things. So I think that's the platform has been very open as well for enabling people, even if it's a very closed platform in the sense that we do everything for you, still it's open that you can bring a lot of your own tooling and a lot of whatever you need. So I think that's super important, because the community then responds and, hey, I will build my own, new version of Node, and I will put it in my own runtime because I want it and I need it, and okay, why not?
Yeah, for sure. And just the excitement in the community and the people working on this stuff have just been mind blowing from the beginning. It's just fantastic and inspiring to see the stuff that people build and share and teach about and talk about, and so much important work and fun work and folks getting involved. And I really like your point about kind of extensible and openness, and this has been something that it's been a really interesting journey for us as we've built Lambda, and to think, like, how do we keep giving everybody the advantages of serverless and all of the great things that people love about it, while also having these extension points that people who want to build cool things, who have a bigger imagination than we have about what to run and what software to run. Like, how do we let them, be completely unconstrained in terms of what they can bring and what they can run and so on. And, it's been a fun product journey as we've thought through how to build this stuff. And it's just been inspiring to watch the community build on it.
Yeah. And let's go a little bit now. I think at least what always drives me to your talks and what I learned your name from is all the Firecracker. And I think that's quite a big innovation from your side and from AWS. And maybe we can start talking a little bit on why you built that, why it was born, because virtualization has been there forever.
Yeah, absolutely. Okay, well, I've got some. Let me actually just get a slide going here, and we can throw that up, and I can talk about why we built something. And so, if you think about the servers that you buy, just like a regular off-the-rack server these days, like an M5 Metal, that has 300 gigabytes of RAM, right? Like when I started out in computing, even 300 gigabytes of hard drive space was an unimaginable amount of storage. And, just like a mainstream server these days has 384 gigabytes of RAM or more. But the smallest Lambda functions, right, they are 128 megabytes. And so you can fit just a huge number of them.
I think your drawing is out of scale.
One of these servers. Right, exactly. We had to, to make the economics of Lambda work, to make the scalability work, to get all the stuff that people love, we have to put lots and lots and lots of these tiny workloads onto a big machine. And we needed to do that in a way that we were just not compromising on security because, an important thing about AWS, we are, security is goal number one, always mission number one. We looked at the isolation technology that was available, the stuff that Linux does in the kernel for containers. We looked at virtualization solutions. We looked at all of those things, and none of those things really met our needs. And so the EC2 team, had been thinking about a similar set of challenges and saying, well, actually, if you look at virtualization, the current virtualization things are big, they're pretty slow, they take a lot of memory. But the laws of physics there, the actual kind of low-level implementation, there's no reason for it to be like that. It can be fast, it can be very scalable, it can be, have very, very low overhead. And so, some of the key engineers in EC2, led by Anthony Ligori, identified this opportunity to say, well, let's build a new virtual machine monitor, and I'll talk about what that means, that is optimized for these kinds of serverless and container workloads. So all of the great security that folks expect out of EC2, full hardware virtualization isolation, but much smaller and much more efficient and much faster by optimizing for serverless and containers.
And this at what year you were starting to think about these things?
This was probably mid 2016 that we were starting to think about this stuff. And I think it's important to mention that, the fact that, we were able to do that and the stuff that had been around in open source wasn't that they weren't doing great work. It's just that we had this opportunity to say, what is really important to serverless? What is really important to containers?
And I think the needs from AWS, as you said, economics of scales are very different than the open source, because that's like the amount of space that you have in the overhead of a virtualization, for example. That's money that is being lost in putting it to resources that we can sell as Lambda functions. So I think that there is a different thinking mechanisms as well, besides security, and the costs are always very important. If we want to build for 1 millisecond, like we do now, we need to be very careful.
That's exactly right, and it's a key point that we were one of the few people who had a real need to run hundreds or thousands of these things on a single machine, because who else needs that?
It's like the Nitro system. A lot of magic has been done there because the needs of AWS are very specific for AWS.
Yeah, absolutely. And so we had this opportunity, and we could say, well, what can we take out of virtualization stuff? And a great example there is if you look at one of the sort of typical things in the market. There's a whole BIOS, right? Like it has to pretend to be a whole computer so it can a computer boot an operating system kernel. And Firecracker just doesn't do that. Firecracker only works today for Linux and for a couple of other kernels that have been ported to it. And it just doesn't have a BIOS. It doesn't go through a traditional boot sequence. It just kind of copies the kernel into memory and starts off running it. And so you could take a lot of efficiency out of that and just really kind of simplify that startup path. And as we went through this, we started thinking about what our customers were asking for, and started thinking about just innovation in the container world in general. And we kind of got to this point where we said, well, we're building this technology. We think it's generally useful to folks that are building serverless things, who are building container-based things, and so on. And so we decided to make Firecracker available as open source and to start building an open source community around that. And so I was 2018 at reInvent. We announced Firecracker as an open source project. We'd been using it inside Lambda for a couple of months.
Yeah, was Lambda running by then? Yes.
Yeah, we had I think about half of Lambda at that time was running on Firecracker, and half was running, with every function inside an EC2 instance. And we were migrating the whole thing over to Firecracker over time, just to get better, faster cold starts and better, better scalability and so on.
So basically, before Firecracker, it was like a little EC2 instance being created for each Lambda function.
Yeah, that's exactly how it worked. And so,
wow.
yeah, we couldn't. EC2 was our best-in-class security boundary. We didn't want to compromise on that, so that's what we built. But that's a lot of work to do a millisecond of compute, as you said.
Exactly. Wow. So now Firecracker really helped you out.
So, and so we built Firecracker and open sourced it, and both the Firecracker team at AWS and the open source community have done a fantastic job at moving it forward since then, adding a bunch of features, adding things like snapshot support for ARM processors, a lot of improvements, performance improvements, security improvements, and so on. And so that's been a really great partnership again between AWS and the open source community as a whole.
Yeah, that's super cool. And now Lambda runs fully on Firecracker. No more EC2 instances.
Yeah, that's right. So Lambda is 100% on Firecracker. Every Lambda function, runs in one or many Firecracker micro VMs dedicated to it. We still run on EC2, and so the actual fleet that Lambda runs is a fleet of EC2 metal servers of various types. And so we still get to take advantage of all of that innovation EC2's done with, as you said, things like the Nitro system.
Yeah.
The last little bit is all Firecracker.
Also in Firecracker, Fargate.
Mm-hmm. I don't know exactly where they are on their journey there, but that's always been the vision.
Yeah, that's cool, because I think all these managed things by AWS is nice that they are fast and somewhere else.
Yeah.
So what was the biggest problems that Firecracker solved when you now have everything running there for the Lambda team? What's your improvements?
So sort of fit Firecracker into the into the world a little bit here. And so this box called untrusted code is the code that you or a customer bring as a Lambda function, and I call that untrusted because I don't trust it. It's code that one of my customers has written. I assume they trust it because it's code that they've written and they love. But it's code that I don't want to ask any other customer to trust, right? Like I want everybody to treat everybody else's code as just untrusted. And then, one of the challenges here is that, as you write a piece of code, you use more and more and more features of the machine, right? Like there are a lot of APIs. The Linux kernel has upward of 300 different API calls. And people want to use that stuff because it's cool and it's convenient and it's a bunch of really fantastic features. But because it's such a huge surface, it's really hard to secure. And so we take the customer's code and then we package it up inside a micro VM with their own dedicated copy of the Linux kernel. So they can use all of those features. They can use all of that stuff with no compromises.
So that's the biggest difference of having a micro container. That's why it's a micro VM, because it has the little kernel in here.
Yeah. And that's a real Linux kernel, right? Like, real sort of current Linux kernel. And below that is this much simpler interface that it uses to talk to the hardware. And Firecracker's goal is it sort of sets up the virtualization for dealing with that interface. And then it deals with essentially pretending to be a hardware device when reads come in and writes and network sends and receives and a couple of these other very sort of low-level hardware operations.
Nice. That's cool. And was the integration with the file system, with the Elastic file system, easier because of Firecracker? Or how it was done?
Yeah, so the EFS integration is a really interesting case here because EFS and NFS are like NFS is just a complicated piece of machinery. It's a big chunk of code because it does a lot of stuff, and securing those kernel level NFS drivers is difficult. And takes a lot of work. And so what we did with EFS is the EFS driver runs in that guest kernel inside the micro VM, and so you get your own copy of it, and you don't have to worry about anybody else who's sharing that kernel because nobody else shares it. It's just yours.
That's cool.
And so it made it really easy to integrate with EFS because, well, at some level. Because it's just packets. By the time it gets to Firecracker, it's just TCP/IP, packets flowing back and forth, and nothing else in the system needs to know about EFS until it gets to the EFS service itself.
Wow, that's super interesting. You just debunked a little bit of black magic for me, because when the EFS appeared, I was like, how they do this? So there is the answer. It's all about innovation. And the other black magic part, I think, is the container support. Do you want to talk a little bit about that? Because for me, having a 10 gigabyte container that performs well distributed around the world is like, how that is possible.
Yeah, let me flip through. I've got some diagrams about that too. There we go. Okay, so actually, let me flip forward. And so this kind of a sort of high-level architecture diagram of a Lambda worker. And so there's one of these boxes that's running lots and lots of Lambda functions. And there's a shared host machine, a shared host kernel, and then every function gets their own Firecracker and their own micro VM. And we came across exactly this thing that you mentioned of, hey, container images are really big. Moving them around, if we downloaded the whole thing, it would take a really long time. People don't want to wait, seconds for a container image to download for a cold start. And so the observation the team made was a lot of people use the same base images for their containers, either the ones that we distribute at Amazon or popular, some of the popular open source products, or some of the real popular Linux distros have container flavors. And so there's a relatively small set of base images, and a lot of the mass of every container comes in that base image. And so what we wanted to do was say, we want to download those base images onto each worker just once, whether it's a custom one that you've built or whether it's one that you're getting from Debian or whatever, and we want to have as few copies of that as possible. And so the vast majority of the time when you cold start, that big chunk base image is already downloaded. But we also wanted to make sure that the unique parts of your container that are your code and your libraries and so on were kept highly secure, encrypted with your KMS key, not sort of mixed in with other people's data. And so this was a challenge, right? Like, we want to be able to share and deduplicate data, but we also want to strongly encrypt data. And anybody who knows, about encryption, when you encrypt a piece of data, it kind of looks different every time because you put these random values in, and it becomes quite difficult to say, this data is highly securely encrypted and it's deduplicatable. And so the team invented some really cool technology where we take a container image, we kind of flatten it down because container images are made of layers like a cake. We drive the steamroller over it to make it one layer, and then we break it up into chunks. These sort of small, just chunks of binary data. And then we use a scheme, so it's been known and around academia and industry for a long time, but I think we're one of the first people to use it in this kind of context, called convergent encryption. which takes a single piece of data and it encrypts it in a way that it encrypts the same way every time, based on the data. Then we take the keys from that convergent encryption, we encrypt them with the customer's KMS key, and then feed that to a kind of low-level file system. And so this is a new component that we built that pretends to be a full copy of your image. But the magic that it does is when you read a file from your container image, the first time you read that file, it knows that it hasn't loaded it before, and it goes and just loads that one chunk of data that it needs. It decrypts it, it gets a key from KMS, and the read succeeds like it was always there. And so what's cool about that is if you put a 10 gigabyte container image in, of which you only access 1 megabyte, we only need to download 1 megabyte of data to do the cold start. And so it's just way faster and it's way more efficient and it scales better. And so
it
and
doesn't
you don't have
matter,
to worry about
for example, if you put a whole application in these 10 gigabytes and then different parts, like different Lambda functions use different parts of your code will be very optimal. It doesn't matter. So that's super cool.
Yeah, and it's exactly that. And if you have lots of Lambda functions, or if you have libraries you don't use, or Java jars you don't use. And this is one of the fun things about innovating in the serverless space is the team has done all this cool low-level work to do this, encryption and the deduplication and this file system stuff. And, I'm telling you about it. We've talked about it at reInvent. But customers just don't need to know about this stuff to take advantage of it.
Nothing you're saying today is necessary for the customers, but I think it's so interesting because it just tells you like what is underneath, like how this is made. That's why I find so interesting, because I don't need to build it.
Yeah. You don't need to build it. You don't need to operate it. You don't need to worry about it. Yeah,
it just works. Yeah, but I find that's super interesting. So the container support was quite a big work and re-architecturing again of Lambda. That's cool. Yeah, I was super amazed when they announced it. I was like, what is this? I was not seeing this coming. No. I think it's great for customers that need to adopt Lambda, didn't know how to get started, because zip packages is a weird thing if you already have a container pipeline. So I think a lot of people were very happy. And I was I have that feeling at reInvent last year, that there was not really any feature that was, because this Lambda is so mature now, that there was any feature that is like, yes, this is something I really need, like everybody need. There was a lot of really cool things that really help specific segments of customers. And that made me very happy, because that means that the service now is mature enough that it's trying to just help all the edge cases and all these. So it was super nice to see that from reInvent.
Yeah, and this was exactly it, right? Like, we'd talk to customers and they'd say, I have my CI and CD pipeline that I use for containers, and I have a different one that I use for Lambda, and I don't want two of them because, who does?
Why to add complexity?
Yeah, exactly. Yeah. The other fun thing about this was, this is something I really enjoy about my job is, we got had this idea to support containers in Lambda, and go off and talk to the team. And, the first reaction a lot of folks have is, no, this is impossible. There's no way we're going to be able to do this. Something that I enjoy about my job is having these, incredibly smart, talented folks around me, and challenging them and saying, yeah, we've got to figure out how to do this. We've got to get this done. So let's go off and be real creative about what we do and what we build. And I think it was a fantastic delivery from the team of thinking through a set of real hard challenges and coming up with some incredibly creative solutions for them.
Yeah, and I think what you said at the beginning, that is you do it once and then like so many people take advantage of it. I think that's very powerful, because if every company needs to build this thing, it can be very tiring, it can be very boring. When I was a developer in real life, I built 4 authentication services. The first one was exciting. The second one was like, I know this shit. The third one, I was like, why you hire me to do this? This is horrible. And the fourth one, I quit the job as soon as they assign me the task. Because doing it over and over again is very boring. But if you have this crazy challenge that is very hard, you solve it and millions of customers start adopting it, it's very empowering. So you will go to sleep feeling very good at night.
Yeah, and developers don't want to do stuff over and over, and operators don't want to operate the same thing over and over, and leaders don't want to pay people to do things over and over, and investors don't want to invest money in doing things over and over, and so this kind of leverage is just so powerful. And it's a really cool thing about the cloud.
It is, and I really like it. One thing that we were chatting, and I think that's also one of the interesting things of Lambda that was announced in re:Invent this year, is extensions. How this sits on the whole alignment of of this internal architecture.
Yeah. So extensions run, let me step through the journey a little bit there. Lambda has always had this integration with CloudWatch and being able to get logs and metrics out of your function. And customers were saying, CloudWatch is great, but it's not what we use elsewhere in our architecture, right? We want to use one of the other many vendors and cool technology in the space, and can you support that stuff in Lambda? And we thought a lot about, can we do special integrations with every provider in that space? But a lot of folks had custom stuff they were doing, and there are a lot of providers and a lot of different applications, and so we said, well, what if we built an extension mechanism for Lambda? An ability for you to bring what I think in the container world people would think of as sidecar processes that can do things like log and metrics and tracing and profiling and security analysis and all of this other stuff. We already had this micro VM, so this place that we can securely run multiple processes. We already had the full kind of interface that, you can send data and you can read and write and all of this other stuff. And so that project was largely about how do we design an API that lets you kind of hook into the life cycle of a Lambda function. Start up before it starts, capture data from its startup, capture data from while it's running, capture data when it shuts down, and then post that stuff off to wherever it needs to go. And that little piece of API design was really interesting. In finding the right balance between helping people get things right and helping people follow the patterns that will make them most successful, but also being really flexible to enable, as we talked about earlier, like the incredibly creative forces that people have, and enable people to solve their problems.
Yeah, I think extensions opens the door for a lot of creative things, because it gives you the opportunity of talking to Lambda before Lambda and after Lambda, knowing what is going on and having like a kind of state kind of connection between that. And people have built crazy things, not only monitoring but for example, one of my favorites is the manage of the application configuration, because that's something that is being always a little bit painful on how to handle it securely. And now extensions allows me to use my app config in so easy and just put it there.
Yeah, absolutely.
And it helps with the cost, it helps with the performance of the Lambda, it just does it in all great ways. So I think that those types of innovations are super cool, because it's opening, I think, again, what we were saying before, opening the door for people to extend the platform, because it's not just this little box now you can play on. Now you have another little box that you can play on.
Yeah, absolutely. Just even more space to be creative and do cool things and solve problems.
Yeah, and talking about creativity, I think one of the interesting things that are cooking in the Lambda function world or Lambda service is Rust. That's something a lot of people are super excited in the, at least inside AWS, about Rust support and building new components in Rust. Can you tell a little bit about that? Because I know very little.
Yeah, We built Firecracker in Rust, starting with CrossVM, which was an open source project out of Google that was written in Rust. We built some of the monitoring components of Lambda in Rust. And as we used Rust more and more in the team and more in AWS, we just really loved the properties that it had of memory safety, which is this really important thing that makes it much easier to write secure code that meets our customers' needs on security. It's great for writing high performance code because there's no heavyweight runtime or garbage collector or whatever to get in the way and require a bunch of tuning. It's a language that it's just a great fit for the kind of security critical, performance critical work that we do in cloud services. And so we made an intentional decision in the serverless space to say, well, let's look at each new component that we build as we build new components and decide whether Rust is the right place to do that. And so, one of the things that we did is we had this kind of 3-layer architecture in Lambda. There's the front end where the kind of API calls come in. That's this massive scale out, just horizontally scalable thing. There's the worker fleet, which these boxes that we talked about, that's where the Firecracker runs and the actual customer code runs. But between them really is what I think of as the kind of secret sauce of Lambda, is the stateful load balancer. And so when you say invoke, it figures out where your function's already running, so you don't need to cold start. It figures out if your function isn't already running somewhere, like where to place it in the fleet to get you the best performance and the best scalability. And it does this across trillions of requests a month, so millions of requests a second, over hundreds of thousands of customers function, and it does all of that stuff in well less than a single millisecond. We looked at the architecture we had for doing that, and we wanted to make that even more scalable and even more performant, and just improve on every axis. The team looked at that and said, well, we're going to build. We're going to choose what language to build this in, should we build it in Rust? And again, like it's very attractive for. It's very attractive for all of the reasons that I talked about. It's just a perfect fit for the kind of cloud work that we do. But it's also something the team didn't know, right? Like they didn't, when I talked to the team, there were folks who knew Java, they knew Kotlin, they knew TypeScript, they knew C++, but very few people in the team knew Rust. And so we had a really interesting conversation about like, how do you balance these technical requirements, like, hey, Rust is better on all these technical axes, versus the non-technical stuff, like, how do we teach the team? How do people learn? How do we get people excited about, the investment of their time in learning a new language? We spent a lot of time thinking about that, and a lot of time, considering what a big investment this would be, and it was exciting in the end to balance those things and think about how we balance innovation in our teams, and how we can build guardrails to make sure that innovation is safe, and how we can make sure that that the team is delivers quickly and delivers the right things. And it was a really interesting journey, and we picked Rust for that. That project is being very successful, and so it's something that we're just using more and more in serverless and more in AWS because we love the properties, and as more people learn it, and as that community grows, it's just become a perfect fit for building the core infrastructure of the cloud.
Yeah, I think Bernard mentioned in his keynote that he was learning Rust. So.
Seems though everyone is these days.
Yeah, but I think that's a great thing that you mentioned, like training the team, and I think that's also really good for AWS as a whole, like a provider of really cool things. When we present a product to our customers, having that empathy of also being all the time learning something that keeps us like out of our comfort zone. So when the customers receive something like Lambda, then, well, we can understand their feeling of like starting something new and re-architecting their whole application to to try to use these services that we tell them they're great. But then, but I already have all these things. How I train my company, how I can... And putting those learnings also into the products, I think it's something that can be really cool, like easier ways to start and easier ways to migrate and all those things that are hurdles for customers to start adopting something new.
Yeah, I totally agree with that point about customer empathy. And it's very easy to say, oh, we've got better technology, we've built a better mousetrap or a rounder wheel or whatever, and you all need to adopt that. And we all know, as people who've been in the technology industry for a while, having better technology or having a better solution is just a really small piece of an overall picture. And we need to understand what are the things that we can do to help our customers adopt things and to move faster and to move with less risk and to make sure that they're meeting the needs of their business and their customers, because ultimately, I care deeply about my customers, and part of that is I care about my customers' customers.
Exactly, and I think, for example, serverless, I think is a great example on how a technology can really need to reshape the way that you do software development when you adopt serverless. Because if you have a structure that, for example, developers are not very empowered and you don't have very good DevOps practices like CI/CD or like infrastructure as code, adopting serverless is very, very hard. So it's better to start working on those things first and then maybe start thinking about going to serverless and not do everything at the same time, because it will be very painful. So technology also comes with different cultures and embracing those things. And when companies are also like you are training your team thinking about those things, it's pretty cool. Like how teams start feeling the empathy. Oh, well, if I'm having so much trouble learning this language, how my customers might feel when we throw all these new things to them. How we can make their life easier and help them out. It's nice to hear that AWS also suffer from we need to learn things.
Yeah, absolutely. And I think that's been a common theme of this whole cloud journey of where our customers need to learn things to adopt the cloud, and we've needed to learn so much to build something that's this big and this important and this critical, and so it's taken a huge amount of learning and a huge amount of kind of curiosity and a certain sense of humility in the face of these like real tough problems that we're tackling.
And you cannot copy paste what other people are doing, because I think the problems that you are working in are problems that nobody had before. Maybe some community, like some academy paper maybe mentioned those crazy things, but I don't think that happened before. So how is that to work on something that is totally new and that nobody worked before? How you tackle?
Yeah, I mean it's super exciting. It's really the dream, right? Like get to think of big things that other people haven't tackled or just haven't tackled in the same way. And we've got great relationships with the open source community and great relationships with the academic community, and they help. Those partnerships help us tackle various aspects of it. But as you say, there's just no predefined answers in this space, and it's really fun. But it's also occasionally humbling, right? Like we just learn that we've done things wrong or could do things way better. And I think another part of my job is helping people through that experience of okay, well, we've done our best, we've been as creative as we can, and we're still not there. And so what's next? And how do we keep our energy up and keep excited about let's go and tackle the next round of problems that we've dug up as we've tried to build this thing that we're building.
Yeah, and how you evaluate that, like, for example, you're building something new, how you know that it's ready for going out there and putting it in front of AWS customers, for example, because that might be a very humbling thing. If every time I went to production with my small projects, I feel like I could not sleep the night before. If I go with a big feature, I cannot imagine how it's like, yes, let's start putting Lambda functions on Firecracker starting tomorrow.
Yeah, one of the things that we talk about a lot at Amazon is kind of one-way doors and two-way doors, and the two-way doors are these decisions that you can take back if it turns out you made them wrong. And launching a product is kind of the ultimate one-way door for us, because as soon as people have started investing in building on top of that, we can't take things away. But one thing we think about a lot on the technical side is how do we turn a one-way door into a two-way door. And so as we were doing something like rolling out Firecracker, we wanted to do that, and we put a lot of energy into doing that in a way that was invisible to customers. Both because we didn't want people to see strange things in their metrics and worry about it, but also because we wanted to be able to put Firecracker out. We wanted to be able to take it back. We wanted to be able to move people incrementally, move one customer at a time. And all of these techniques of being able to do things incrementally they're a little bit expensive to build. They add complexity, but they're worth it every time, because if we can do a big migration like that step by step and take steps forward and then take steps backwards, we can do it much more safely. And just being able to, instead of, well, here's a flag day where we go from like 0 to 100, say, well, today we're going to put 0.1% of customer traffic on Firecracker, and we're going to watch that real carefully. And then tomorrow, 0.2, and then if we find problems, let's go back to 0 and fix those. And so that iterative process is a big part of it. And the other one, is just making sure that everyone involved has a really high bar. And one thing that's really interesting at Amazon that you might not see elsewhere is like, a lot of our executive leadership will actually try out our beta products, right? They'll be clicking around in the console or building their hobby. An old boss of mine used to, build his home automation system on all of our betas. And so every day when he'd go and like switch on his lights and they wouldn't work, he could say, here's something that I found, and we need to fix. And so, just insisting on the highest standards is also an important point of that, from a security perspective, an availability perspective, an error rate perspective, and so on. And that's just a constant lifestyle of both hitting a high bar for launch day, but then continuously improving and improving and improving and holding ourselves, accountable for the problems that customers see.
Yeah, and I think that's the part that customers see every time that they report bugs or they complain about something. That then some months ago things happen and like, oh, this is fixed. I think that's, as a customer, when that happened to me a couple of times, I was one of the biggest customers in Finland working there, and things got fixed and we were like, did we have an impact, or were a lot of people complaining on this? But we felt so important because that was our complaint. It makes, at least for us, it was like the best day when, oh, that's fixed. Now we can remove half of this code. Let's throw it to trash.
Yeah. I mean, it's fantastic when we get to do stuff like that. And things like that come in through support and so on, and all the kind of official channels. But I also just love it when I see, developers in the team saying, here's somebody complaining on like a Reddit thread or on Twitter or on Hacker News or whatever about something we can improve. And, just everybody kind of taking ownership for the experience that our customers have.
I think that's kind of the mentality of AWS. It's like the first leadership principle, customer obsession. We'll leave for that one. Yes, and the last question to round up the interview, because I think I just want to know, what is your favorite leadership principle? Because you were talking about like 20 of them. The 14 of them, I think you mentioned. Yeah. So which one is your favorite?
I like think big because it's this open-ended challenge to think about our customers' problems and not only the ones that they're telling us about, but also the ones that we think they're going to have in the next decade. And as an engineer, being able to look at trends in the industry and trends in technology and trends in hardware and think just really creatively about where do we think we're going? What problems do you think our customers will have? What does just the world, the changing world, mean for our customers' businesses, and how can we help them with that? It's just helps keep the energy up every day, and helps us avoid being too focused on this week or this problem or next month or the next launch. Because we have to, constantly remind ourselves, and are asked to constantly remind ourselves about, let's look around corners, let's look to the future, and challenge ourselves and challenge our teams to be creative about the way they think about customer problems.
Yeah, and I think all these amazing things that happen in Lambda is a great example of challenging and raising the bar and thinking about things that I think nobody even thought that something like Lambda could happen until Lambda happens. Like, all the time, kind of like, what the hell is this thing? How is this happening? How is this possible? And I think now you're working on that type of black magic in the database sector. So
yeah. One of the things we're working on and are very excited about is Aurora Serverless v2, and just bringing, more and more of this, serverlessness to the database world, and helping customers not only with their scale out stateless problems, but also with their hardest data problems in transactions and in analytics and in NoSQL and all of this stuff. And there's just so much energy and excitement about serverless in all of its forms.
Yeah. And Dynamo is one of my favorite products, and I'm really excited now to see that Aurora is coming with like all these serverless things, because I hate to put myself in an instance and in a box, and I don't want to care about that. I want to just throw queries and get queries back. And
that's what we want.
That's what I want. So I might talk to you again maybe at the end of the year, so you can tell us a little bit of Aurora Serverless 2 and the black magic behind it.
I look forward to it.
Because now you talk about the black magic of Lambda. So I'm super happy to have you here, and thank you again for your time.
Well, thank you. This has been a fantastic conversation. I've really enjoyed the opportunity to share all of this with folks, and thanks.
And there is a lot of information about Firecracker if you want to go deep. There is many links in the description box. There is a paper you wrote, a couple of reInvent talks. There is also about security you talk about in reInvent this year on how Lambda does security. So if people want to go more in depth on all the topics, I leave all the links in the description box, so they can get all the knowledge of Lambda and how it works.
Good.
So thank you again, and have a great day.
Yeah, you too.
Ciao, ciao.
Cheers.
Thank you for watching this video through. If you like it, share it, and don't forget to give it a thumbs up. That always helps my channel to grow. Let me know in the comment box who you would like me to interview next. I want to do interviews that help you to understand serverless and the cloud in more depth. And I see you in the next episode of FooBar. Ciao, ciao!